So, uh, welcome. Today we are going to look at the design definition and its procedure. Let's try to understand the meaning of the word design elaborately. So, what do we understand when we say a wallpaper is designed, a car is designed? So, at the outset, we may relate to its aesthetic appearance, but actually, aesthetics is only one of the aspects of the whole design process. Then, what exactly design means? What is its origin? So, design basically came from a Latin word designare, which means to designate or to make out. So, the dictionary meaning is that to outline, plot, plan an action, a work, or conceive, invent, or create. So, what do you conceive or what do you create? You basically work on a plan. You formulate a plan for satisfying a specific need, or you solve a problem satisfying certain constraints. So this is one aspect of design. Or a problem can have multiple solution also, where you can develop many possible solutions and then optimize them, narrow down it to feasible one. So this is an iterative process. Even this is also design. So essentially, when we do so, it will result in some physical reality, that is a product or a system which will function safely, reliably, right? But at the same time, it must be competitive. So the designer must ensure that it is competitive in the market, easily usable, easily manufacturable, and you can sell it easily in the market, right? Thus, design is an innovative and an iterative process, because we try to develop multiple solutions, right? And it is also a decision making process. When we have multiple solutions, which one to select, so we perform an optimization process. So it is basically a communication intensive activity, because see, for a given problem, you might have the solution in the abstract form in your mind, but how do you communicate it to your neighbor? You must have a tool to share it. So we basically use language and then pictures, right? So you must be proficient in a particular language, and as well as you must be knowing engineering drawing. So we basically use engineering drawing, though not artistic drawing. And we are mostly concerned with engineering design rather than artistic design, because we our focus is on learning engineering, right? So what exactly engineering design is? It's all about designing a system where you apply various principles and techniques, right, in defining or creating a new device, process, or system which are sufficient to permit its realization. So when we say engineering design, it means a system design which has several components, where each component can be from the same discipline, or it could be a multidisciplinary one. So today we mostly have multidisciplinary system. For example, you take an automobile. It is a combination of various products from different disciplines, right? In this course, we are concerned with only one aspect of engineering design, that is machine design. So as defined earlier, machine design means basically the creation of machinery that works safely, reliably, and well. So a machine is an apparatus which will have interrelated units that will modify a force or motion. And these interrelated parts or units are known as machine elements. So what is our objective? Our objective is to calculate the forces and motions, or the changes in energy which are required for determining the size, shape, and selection of material for these interrelated parts. That is, we are looking at the detailed design, the geometric aspect of the interrelated parts. Select the dimensions and materials. That is all. This is our scope in this whole course. So, machine design can be classified into three types. Number one, adaptive design. So, in this case, the designer will have already a set of designs and has to make only minor changes in the existing design for creating a new product. This is very much similar to group technology. I hope you would have heard about group technology, right? Where you will have already existing designs, pull out any one, and then do small changes in that. That is it. Second one is development design. In development design, the existing designs are modified, but uh, a new idea will be developed rather than making only minor changes. A new idea or a new product will be created by adopting a different material and manufacturing method. Third one, new design. In this case, the design evolves from scratch, right? So a lot of research and technical ability and creative thinking is needed to do so. So only those persons who have qualities of sufficiently high order can take up this new design. One cannot design a product or a device without due regard to the parameters that influences design. So we must know those parameters. So to name a few, first one is the functionality, which will influence the design, the strength of the material that is used, distortion or the deflection, the amount of deformation due to the applied load, stiffness, wear, corrosion, size and shape, safety and reliability, cost and weight, life, manufacturability, and maintenance. This is just a few of them. The list actually is very large. We shall look into these aspects in detail in the upcoming sessions. Now, let's look at the design procedure or process. So, this basically starts from the identification of the need. So, how do we recognize the need to create a design? Sometimes we might experience a kind of discontent, a kind of uneasiness, a feeling of something that's not right. So, these are the symptoms, right? That will, or when we face some adverse situation. So these aspects actually trigger us to recognize a particular need. So once we identify a need, the next step is to define the problem. See, the statement of need and definition of problem are totally different, because the statement of need is basically vague, right? It is not clear and specific, whereas the statement of problem is very, very specific. It clearly says the magnitude of the input, output, the material that must be used, the dimensions of the interrelated parts, size, shape, and the volume occupied by the part in the space, and its safety, reliability, what is the manufacturing process that one must use in creating this device, and so on, right? So these details will be specified in the problem definition. So once you specify all these parameters in terms of numbers, just check again, you go back to the previous phase whether it is satisfying my need, right? If I create a part with all these specifications, will my need be satisfied? Well, if so, then proceed to the next step. So in the next step, we synthesize, that is, we create, innovate, or develop a design right? Such that it will satisfy the problem definition, and in turn it will satisfy my need. There is a, you can see those arrow marks, right? As we said earlier, it is possible that we can have multiple solutions for the same problem. So when there are multiple solutions, you can check all the solutions, right, against the problem definition and identification of need, whether it is satisfying. If all of those multiple solutions are satisfying the previous two steps, you proceed to the next step, where you analyze the competing solutions, competing schemes that you have developed in synthesis phase, right? And in the mean process, you may have to modify, do some modifications. So that is, you go back to synthesis while analyzing, and then again compare against the other solutions. Again, you may have to check whether it is satisfying the problem definition, whether it is satisfying the need while analysis. So these things we will do during analysis of multiple solutions. Then you run an optimization exercise to select the better one, right? When you are done with that, you are proceeding to the next important step, that is evaluation. So how do we evaluate that better design, what you have arrived at in the previous stage? Earlier we were doing a prototype testing, but now with the advent of computers, we are doing or we are evaluating the design using numerical simulations. Okay, so which is drastically reducing the cost in comparison to the prototype design. So during this testing, we will see whether the product is functioning safely and reliably, whether we can maintain the product easily with less cost, whether we can manufacture it easily, and so on. So when you do all these things, check all these aspects, and finally arrive to a situation where yes, this design is a better one, it has satisfied the prototype testing. Then comes the important thing, presentation. So all these phases have occurred only with respect to you. Now that you have to share it to your neighbor, could be a team manager or could be any client, right? So you must be in a position to prove that your design is the better one. You must be in a position to sell this, otherwise all the exercises done in the previous steps will become a total waste. Okay, so these is actually about the design process. So when we design machine elements, there are certain basic requirements to be satisfied. One is that the machine element must have sufficient strength in order to withstand the applied load, right, without any failure. Only then it can function. Then it must be rigid enough, right? That is, it must not deflect or deform. Then there must not be any loss of material, right? That is, it must be wear resistant. So this wear resistance can be accomplished by performing surface hardening processes, heat treatment process. And it must have minimum dimension and weight, because ultimately we have to reduce the cost of our design, right? So when we look at this aspect, you must not overrule the previous three, right? It must be easily manufactured. It must be safe. It must not, affect the operator or any life around us. So that is why we incorporate the principle of redundancy. But when we incorporate more redundancy for all the parts, then obviously it will increase the weight of the component, and hence its cost. So redundancy wherever it is essential must be incorporated. You cannot have redundant part for each and every machine element in your machine. Then this is the most important thing. As I said earlier, your design must conform to the local standard, either a national or international, whatever that local body follows. as far as the design, dimension, grade, and material concerned. Only then you will get a certificate to manufacture. Then it must be reliable. What do we mean by that reliable? When we say reliable, it means that it is the probability that with which the machine part will perform its function under the set of given operating conditions for a specified period of time. If it does so, so when we say that this is the life of the product under these conditions, and when we use those product under the specified conditions, it must work satisfactorily. Then we say it is reliable. Then maintainability, yes, we must spend less time and cost for maintaining, and minimum life cycle cost. When we say life cycle, it is the total cost to be paid by the client until from purchase, operation, maintenance, and disposal over its lifespan. So when we design, we have to consider all these factors. Okay, so these are the basic requirements of machine elements. So these are the references that I have referred to. If you want any additional information, you can read these textbooks. Thank you.